So hi everybody, I'm Johann Lombardi. I am a senior distinguished technologist at HPE and also the chair of the technical steering committee for the DAOS Foundation. And today I'm going to present an update on the TSC and the DAOS community roadmap. So first of all, a few words about the technical steering committee. We meet once a week. We have a rotating schedule to accommodate all GEO. So we have a meeting which is more US, Europe, EU friendly on Monday, and then the next week is on Tuesday. Well, late for me as based on Europe, but more easier for people who are more in the west of Asia. And Australia and so on. During this meeting, so it's open to anybody. You can join. We need to just register through the LFX website. We define the roadmap. We discuss the roadmap, the future, the roadmap change, and so on all together. And we also review the blockers for the release. Lately, one of the main activities to review 2.8 blockers, but also candidate to be added. And also when we prepare a new release, we work on the SRS and all those requirements for the future release. Sometimes there are also some specific discussion on technical topics. So this is really the forum for all technical discussion. Whether or not you are a member of the foundation, you are welcome to attend. So this is the current roadmap that was updated like a few weeks ago. And so we made some major changes into this roadmap. So 2.8 is on the way. We are close to tag an RC1. I think we have only a few blockers remaining, which are fairly under control, like SPDK upgrade and so on. So those we really hope to tag RC1 soon, and that will be the first community release under the DAOS Foundation. I haven't shown DUG'26, but it's being discussed. This is an HP release where managed by HP, and 2.8 will be the first community DAOS Foundation release. In terms of feature, we have it 2.8. We have been reducing it a little bit over time to make sure that we can release it on time, even we're still a bit late. I will go through some of those features into the next few slides. The PyTorch data loader has been presented a few times, and I'm not going to present it again. So that's the main one of the main features, and we'll see in the next few slides details about those other features. The major change we did recently is really in the 3.x release stream, where we basically decided to split. Initially, we only had 3.0 and future releases. We decided to split into 3.0, 3.2, and 3.4. In 3.0, the goal is really to focus on the PMM-less mode, the non-PMM support phase 2, which is one of our major feature that is indeed really on DAOS to be able to overcommit the amount of metadata in memory compared to what is stored on the SSD. And that's an important one, more particularly nowadays with the DRAM pricing going crazy. So that's really one of the main features we decided to stick in 3.0. There are others like catastrophic recovery improvement. So we did some changes in 2.8, but there was still some leftover changes that didn't make it. So we're going to complete those into 3.0. Protocol changes for multi-provider. We have this ability, this feature branch we developed quite some time ago with the ability to run multiple providers. So there is a primary provider which run on every target extreme, and then they have dedicated extreme for a secondary provider, lower performance. So it's typically a use case when you have a main fabric and you want to re-export DAOS through TCP or another protocol, but to a set of external compute node. There are some changes required in the protocol to support that. So that's what we're going to do in 3.0. And the feature for multi-provider will only be supported later in 3.0 because some stabilization and testing, 3.4, sorry, is required. There have been some work on hard links. I will present more about this into the next few slides, and incremental reintegration. In 3.2, so before in 3.0, we had rolling upgrade, and there has been some important RAS feature we wanted to prioritize over rolling upgrade, because at the end of the day, rolling upgrade makes sense only if you are fairly robust on the RAS side. So we decided to add network multipass. I will present a little bit more as well into the next few slides for DAOS 3.2. That was the main change, and incremental rebuild, which has been in the work for quite some time now. The goal is to make it GA in 3.2. In 3.4, the intent is to work on rolling upgrade and to support this feature once we have set up some solid foundation for RAS support. And also the ability to support full domain beyond server. So today we support full domain, but the only domain are the engine or the server. And DAOS has the ability where you can populate, you can gather a node that are part of the same full domain, like all not connected to the same switch or inside the same rack or whatever user full domain that you want to define as an administrator. This feature is partially implemented, and the goal is to finalize it, test it, and validate it for 3.4. Also, we like to do a tech review for QLC, which again is becoming more important lately. And the intent is to be able to still have TLC SSD on the node to store the metadata blob and the WAL, but use QLC for the data blob. And then we have this generic bucket of functionality that we would like to support in the future, but didn't find yet its way through a specific release in the roadmap. Any question before I get into the next level of details about the overall roadmap? Okay. So the Gin branch status, so we have, as usual, a release directory on, if I can say, on GitHub, where we put all the releases. So release/2.6 is typically the upcoming 2.6.5 version. So 2.6.4 and then 2.6.5 about to be released, managed by HPE. Master will be the future 3.0 release. And something that is often confusing is that we name the test build based on the Q.oddNumber.x numbering. So typically, we're going to start doing 2.950, 2.951, 2.952 eventually. That will be that are the test build for the future 3.0 release. So only the 2. Even number are official release, basically. The odd number are just test build. We, maybe a month ago or so, created release 2.8 that we forked out of master, which will be the upcoming 2.0 version. And then when it will be a 2.1 and so on, this will be stored on this release/2.8 branch, right? And so we do that feature that are targeted only for 3.0 will land to master and are not going to impact 2.8 going forward. So in 2.8, we had this entry into the roadmap called better default. So there are several lessons learned from the Aurora deployment and also from LRZ. And the main idea is that we want more reliability by default. Historically, when you set up DAOS, initially you have a ref of 0, you have no checksum, you have like the worst possible reliability parameters. And we decided to flip it and basically had more reliability by default. And then people who want to reduce it will explicitly do it. It means that by default we will get lower performance now, because obviously there is no free lunch. Adding those features kind of impact the performance. But if you want to reduce it, you can always do it by changing at pool creation time or container creation time the parameter. So let's go through this list of property changes. The pool property changes we did, first of all, we put RF3 as the default on the pool RF property. There was an issue, obviously, if RF3 required at least 3 full domains, 3 nodes. And we had a debate internally on what do we do if we don't have enough node to satisfy RF3. The first idea was to return a failure, but that can be frustrating for someone who just create a single node system to always have to specify RF0, RF0, RF0. What we decided eventually to minimize impact on users who might be used to just create the DMG pool create by default without specifying any parameter, is that the DG container creation, is that we decided to lower. If you don't have enough node for 3, you only have 2, we will do RF2. And if you have only 1, you have RF1 or RF0. So this will be based on the number of node available in the system. And as soon as you have enough, this will be RS3 and forward. There was also a problem. By default, there is no space reserved for rebuild, which means that if your system is full and you exclude one of the node, then rebuild won't complete. Because we have the feature to reserve space, but the default was just 0%. So after several discussions as well, we increased it to 5%. And this is the space reserved across the board everywhere, right, on all the node to be able to satisfy rebuild. And since rebuild is declustered, we made some calculations thinking that 5% is a reasonable default number. The default TC size used to be 64K, and based on Aurora benchmarking and also at LRZ, we realized that actually 128K. It requires a larger full stripe write, but provide better performance with the current hardware. So we changed the default. On the container property, we decided to enable checksum by default. So when you create a container now inside the pool, checksum will be enabled by default on the container. So it means that the client will set a checksum on write, and it will be stored persistently. And on read, we will verify the checksum. But in addition to that, there is another parameter when you can force checksum verification on write on the server side, so that when you send the RPC, the update RPC over the network, instead of just storing the checksum, and if something was wrong over the network with the data transfer, get the error of the data associated with the checksum later when you read. In this case, we will do a proactive verification on the server on write, and obviously impact a little bit the write performance before storing it. So that if the checksum when the data is corrupted while the data were in transit through the bulk transfer, for instance, in this case we will fail the write instead of failing the read later, right? So we have also enabled this parameter by default. So that's what we did in 2.8. There is more to come. Some of those changes might be more controversial under discussion, but I put them in there for the sake of completeness. We are discussing mainly POSIX, the default container type when you do a DAOS container create. So you will have no need to specify -t POSIX. But obviously there are those set of containers who really don't have no type, then we have to have a specific -t, none, or whatever is the other default type, which is non-POSIX for more like the native access to the DKA key API. The default rebuild throttling is pretty aggressive. So we discussed it just before. There are other things we might want to do before changing the default, but we might want to make it less impactful on the IO by maybe using even a different metrics than what we have today. Another things we were discussing, and it's still maybe a bit controversial as well, is whether eventually when the checksum scrubber has been stabilized, whether this is something we want to enable by default now that we have checksum enabled. That's the thing for better default. Packaging, there was a contribution from Google on the new packages for 2.8. So the way we create packages is different in 2.8 versus 2.6. In 2.6, we had different Jenkins pipeline to create packages for SPDK, for LibFabric, and so on. And it was a bit cumbersome for people who wanted to just generate packages by themselves. So we moved everything to be able to create the DAOS packages inside the DAOS repository. And now with just Docker, you can just do the command line I specified here. It's going to pull the Docker image for whatever operating system you want. I mean, that we support, obviously. Generate the packages, and typically now we can generate Ubuntu packages fairly easily for client and for server, and then extract them for the Docker container, and then install them. I've been doing that a lot lately, and that's very friendly. There are some changes into the naming convention because we use some specific tool to generate the spec file and the Ubuntu Debian file, for the packages, and there was some slight changes into the different packages, so we had to rename by putting the DAOS prefix in there. Self-healing and specific rebuild control. So there was just a presentation, so I'm probably going to go fast on this one. But the overall idea was really to provide system property and pool property to be able to define when rebuild is started at the system level automatically or on a per pool level. And Tom, Ken, and Liwei presented those. So probably I can move on this slide. But um, this is really when you have a big system with a lot of pools. Sometimes there are some resources management issue, and we wanted to expose those capability to the administrator because today, when there are issues, you just have to sit and look at the system, and you just fail if you consume too much resources. So at least now you have an API to be able to stop, rebuild on some pools, or delay it at least. That's obviously not ideal. Eventually, we want uh, better resource control on the system, but we thought that would be better also to give some API to the user to be able to implement a specific behavior, to work around some issue, or to implement some policy that they might want on their side. So non-PMM is one of the big feature. I have this generic slide that I've used a few times just to explain what the non-PMM audit is. Basically, before we had just the data blob with persistent memory and this mmap file, which was stored in persistent memory using PMDK. And now the new model is that we still have this mmap file in DRAM that maybe we will remove eventually, but so far we still have it. And then we have a copy of the metadata file, the map file on the SSD, plus a write-ahead log while on the SSD as well. You can put any of those three blobs anywhere you want. They can be on the same SSD or they can be on different SSD. DAOS support all those configuration. And the difference between in phase one, the size of this map file equal the size of the metadata blob. So it means that you cannot create more metadata than the amount of memory you have. In phase two is where you can have this metadata blob that store more metadata that is effectively stored in memory. So we overcommit to some extent the memory. And then there is this overall notion of eviction when you have some metadata that are unused inside the mmap file, and then to be able to load more, right? Because this space is smaller than this space. There are also some discussion about being able to serialize some of those metadata to the data blob. We call it this flattening process, but this is delayed. This is not implemented yet, and this is delayed to future releases. So let's look into what is supported in 2.8 and 3.0 with regard to non-PMM support. So this overall system is based on bucket. So we have bucket that are basically of 16 megabytes, and where we store the metadata that are effectively stored into this metadata blob. And we load those buckets from the metadata blob to the DRAM back and forth. And the number of bucket load in phase 2 inside this mmap file is a subset of what is available into the metadata blob, right? We have the notion of some bucket, some zone that is non-evictable, and this non-evictable zone can grow. So just to give you some order of magnitude, I got some number from you. The bucket size today is 16 megabytes. The time to load the bucket is 4 milliseconds. So that's obviously a major change for us. Before we had all the metadata memory map access directly in memory, but now you have to potentially have a cache miss and gonna have to load this 16 megabyte. So a lot of tuning will be required to get the best performance, and also to be able to do read ahead and to know what bucket to access. But that's the baseline. So with the single bucket, today you can store up to 500 megabytes of data if you do 4K IO, or 137 gigabytes of data if you do 1 megabyte IO. The limitation you have in 2.0 that will be addressed in 3.0 is that for the time being, an object is strictly limited to one evictable bucket per object shard. So one object on one server can only have one evictable bucket. So obviously, when you exceed the amount of data, you can still create a file that is bigger than this evictable bucket. But when you exceed it, you fall back to this non-evictable zone. And one issue you will have is that obviously as the file grows, it goes back to the non-evictable zone, and the non-evictable zone might fill up. The non-evictable zone is pretty static compared to the evictable bucket. So it might mean that sometimes you can have no space uh, because you just filled up the non-evictable zone, while there are some other buckets that are evictable that are free, right? But since one object is limited to one evictable bucket, you have this restriction and leading to spurious space and so on. So those are issues that will be addressed in 3.0 and why it's a feature preview in 2.8 as well. We also have a new allocator for phase 2 that we also use in phase 1 in 2.8, like for the memory allocator, which break away from the PMDK allocator. There are also some challenges related to object fragmentation when we have I/O and aggregation running at the same time that can lead to performance degradation over time that we are working on. Hard links. Softlink has been supported in DFS from day one, but we didn't support hard links for one specific reason. At that time, is that we store actually the inode attribute in the parent directory entry. So there was really no way for having a two directory entry pointing at the same inode and an inode attribute because we store it into the entry. So there was a one-to-one mapping between the high node and the directory entry. And the goal was to provide better performance, right? So otherwise you have to do lookup and then you have an inode table somewhere else and you do another round trip to another server to where it might be where the inode attribute might be stored. We made this choice. I think it was the right choice for performance. But the question is, why are we considering hard links now? So we run into some Python package manager, which seems to heavily rely on hard links. They have some option to support soft link, but they seem to be broken. And we definitely want to be able to support this package manager. And also some backup utilities are using hard links. So the idea is that, oh, can we support hard links without impacting the performance? So Sherin has been doing quite some good work here, where basically we have implemented, we keep the format at the beginning, the same one, the original format when we have the inode attribute inside the parent directory entry. But when we detect that someone wants to create a hard link, we basically fork to this new module where we have a global inode table when we will store all the inode attribute for a specific inode. And then we update the first link to the file and then the new link to the file to go through this indirection table. And the layout is done on the fly and is consistent because we use our internal distributed transaction for consistency. So there is a design here from Sherin, and you are welcome to have a look at it. There are some PR already, and there has been some early testing done by some community member, which are very encouraging. And as I said, with this module, we only impact performance for hard links, but that's performance of hard link might not be that important, and to some extent, this is the feature you use. So we have to go through some sort of indirection table. Incremental reintegration is this feature where, so today when we exclude an engine and we reintegrate it, we wipe out everything on reintegration, right? Even if the SSD survived, I mean, we can exclude a node because some SSD died, and then we replace the SSD. In this case, it's legitimate to restart from scratch, right? Because we lost the data. But in many cases, when you have like network instabilities or an issue that are unrelated to the SSD, when you restart, usually the data is still available. But still, DAOS today in 2.8 and 2.6 will delete everything and rebuild everything from scratch. So when you have node with a lot of data that have been stored, it's a lot of data to rebuild, and more particularly for reintegration. So for rebuild, it's completely declustered. We not fail. We decide where all the objects are distributed, and everybody calculate in parallel. So we distribute the load across all the nodes. But for reintegration, we bring it back. So even if all the nodes contribute by sending data, at the end, you want to restore data on one specific node. So you are usually limited by the SSD and network capabilities of this node, right? So usually it's slower. So this is why we have a lot of data to rebuild. That will be interesting if when you do the reintegration, the data on the SSD is still available to do incremental reintegration. And you know, DAOS is version based. So we have this epoch mechanism when we track every IO at a different epoch. And actually, we can define at what point we got evicted, excluded from the system at a certain epoch. And instead of rebuilding the whole history from scratch, we can just rebuild from this specific epoch. So that's the system or the feature we are trying to implement now. Obviously, the devil is in the details. It's not that easy, and there is some challenges. For instance, um, when you have an object that is getting punched, so after the node has been excluded, an object is punched, then aggregation run. At that point, we will delete to reclaim space the whole history for this specific object. But then when you reintegrate the fail node, the node that got excluded, you need to know that you need to remove this object. But unfortunately, after aggregation, we removed all references to this object everywhere. So there are different ways to address that, and the team is working on it. Also, there are some testing is important, and also there are some cases where we just cannot do incremental reintegration, and we're going to have to fall back to full reintegration, but trying to minimize it. One nice feature, I think, what to do is that if the system, there was no update while the node was excluded, which is likely when there is network instability, that would be very great when you reintegrate the node that it's just instantaneous, right? By being able to verify the epoch number and no update were done anywhere. So the system is just the node straight away. Network multipass. So that's the idea from a high level where in the baseline DAOS node, we have usually two engines with two network interface card, and each engine is bound to a specific network interface card. And if you lose this network interface card, or if the switch to which this network interface card is connected is running into issues, you lose the engine. And in this case, you trigger rebuild. But there might be actually the ability on the node to reroute the traffic through the other NIC. That will have an impact on performance, but at least we won't go through heavyweight recovery protocol because you can have a lot of SSD capacity attached to a single SSD, to a single engine. So there are really two use cases we are looking into. The first one is resilience. So all the traffic is still sent through one primary card on both client and server. So we use one node, like we do today, one pass. And then when a server has a failure, we on the fly reroute the traffic through the other interface. We fail back to the secondary route temporarily, and as soon as the primary route to this specific engine is fixed, then we switch back to the original route. Why using this model is in DAOS we have a problem with the number of connection we set up between client and server. And if we always use the two route for every traffic and we do channel bondings, there might be some worry at very large scale that we consume too many endpoints, right? So this is why we still want to support use case 2, where instead of having a primary and secondary route, we always round robin across all the interface on both client and server. That will provide maybe better performance. We'll see. Better reliability for sure. But the problem is this number of connection that is set up that we need to evaluate before making this the default. There is also some question related to Swim. Or do we want Swim to have any visibility into this multiple interface? And I think the answer is yes. And one proposal we are looking into is maybe for Swim, we can send the RPC over the two pass, right? We don't have this problem of too many connections set up if it is just for Swim. And when different server want to ping, when node A decide to ping node B, instead of pinging through the primary pass, it can send two RPC in parallel through the primary and the secondary pass. And as soon as it gets an answer from one of the two, consider that the node is alive. There are several design considerations that we can look into. So we're working on this with the cart team. And the idea is really to have this feature implemented in cart. And basically DAOS to try to keep the DAOS engine and libDAOS fairly untouched as much as possible. They might still see RPC, so typically I think it's fine to bind an RPC to a specific NIC at RPC creation time. But obviously, when there is a failure, the RPC might time out and might have to be resent by the engine or libDAOS. But the alternative path, the endpoint.
Johann, I think we lost your audio. Can you hear us? Okay, I think his headset died.
Hello?
Okay.
Sorry, my headset was turned off. I just realized that. Sorry. So let me restart on this slide. So the Go, there are some features for consideration from contributed from Enacta that are not in our roadmap yet. So the Go API bindings. So Go doesn't support interception library, unfortunately, because it's not based on the libc. But there are cases where we might want to support DAOs with Go services, and one of them, for instance, is the Varsity S3 gateway that we are actively looking into. So the Go API bindings will allow us to integrate Varsity directly with DFS. Python, we have this PyDAO stuff, which basically provide a Python dictionary on top of the DAOS data module. But we never really had good support for file system interface. And there is this Python FSPEC integration where we can integrate now directly using Python DFS, basically the link with DFS. Enacta has been working on two other interesting projects, one related to HSM and tiering, where they supported tiering with very minimal changes to DAOs that need to be evaluated. And they also work on an alternative to diffuse by having a new kernel module using its own mechanism for kernel user space communication, not using the diffuse fuse framework at all. So that can be interesting to evaluate and benchmark against diffuse to see how it performs. A few notable community efforts. There is a paper from HPE Labs on evaluating the DAOS client stack on the DPU that I think is worth mentioning. That was presented at TSC. We recently had Alibaba joining the TSC, who is interested in DAOS and proposed to split the control plane into two processes to basically have the Raft engine running in one process and all the RPC handler manager into the control plane in a different one. And they have some use case for that related to resilience and being able to do a live upgrade that we will be discussing with them. For many certification like NVIDIA and other certification in AI space, there is more and more need for multi-tenancy. And we are in a good place here with the pool system, but we miss some feature. We miss support for VLAN and we miss support for a better isolation for who can see the pool, even if you are an administrator. So we have been working on this design from MGMAC about per pool certificate for multi-tenancy. And the idea is that even if you are root on the client node, there are only a certain set of pool that you can see, right? So the same system can have access by two sets of client node. This set of client will see a subset of the pool and this one another subset of the pool. And we can basically assign different pool to different set of clients. There's also another activity to support different authentication type. I put the link to the design documentation. Basically, not just the POSIX permission and what we have today, supporting Kerberos and so on, that has been proposed. A few link resources for the foundation, GitHub, and documentation that you are welcome to look at. Any questions?
Hello.
Yeah.
I have a question.
Mm-hmm.
Yeah, I see the rolling upgrade feature was scheduled at
Yeah.
3.4 version.
Yep.
Yeah. What are the main challenges for a rolling upgrade? Why so late?
The main challenge is that we need to do several protocol changes between the servers. Today, the protocol doesn't really support rolling upgrade across the server. We have done some changes to have the client that can. You can upgrade the server while the client are running, and there was some some activity there, but between the server to be able to rolling upgrade, we need to do a better versioning of the system for the cross-server RPC protocol and being able to support 18 region use version. Then we don't have this support in place. And we also need to do a lot of testing, right? We don't have a good infrastructure in our CI yet to really support a rolling upgrade. So we'll have to invest a lot on this side.
All right. Does the rebuild has an impact on that? Is it depend on the incremental rebuild?
No, it doesn't really depend on well, there are several ways to support rolling upgrade. If you exclude the node and then you upgrade and then reintegrate, then in this case, yes, incremental reintegration will help so that you don't have to rebuild everything from scratch, right? So there are some features available in 3.0 and 3.2 that will make a rolling upgrade maybe more viable, right? For during the downtime. But that's not a strict requirement. We could have decided to rebuild from scratch, right? That will take more time, obviously.
All right. I see. Thank you.
You're welcome. Any other questions? Okay, thank you.